Our next topic is nature of heat and work. Okay, heat and work are the two ways by which a system can change its energy. Which system? A closed system. So the energy of a closed system can be changed by two modes, heat by work. Okay, now what is heat? We know that, and how the energy of a closed system changes due to the transfer of heat. So if the heat is absorbed from the surrounding during the process, the heat is absorbed from the surrounding, the energy of the system will increase, and if the heat is lost into the surrounding from the system, that is, there is loss of energy from the system, the energy of the system will go down. So remember that the energy of an isolated system will increase due to absorption of heat. Okay, and for absorption of heat, you will indicate this absorption of heat as plus Q for the system, and if heat is given out into the surrounding, or that is evolution of heat into the surrounding, is loss of energy and is indicated by the minus Q. So plus Q means increase in energy and minus Q means decrease in energy. Okay, so heat is one of the way by which the energy of a closed system may vary due to absorption or evolution of heat with the surrounding. Due to absorption of heat, the energy of the system will increase, and due to evolution of heat, the energy of the system will decrease. This absorption or evolution of heat is indicated by plus and minus sign before the symbol of heat, that is Q. Now the second mode of transfer of energy is work. Now we have studied about work in our school, and we have studied it as the work is the product of force and displacement. It means that what is work? It is the movement of an object through a distance d in the direction of application of force. Suppose this is the object which I want to work upon. So in the direction of application of force, the object will move by some distance d. Okay, so how I can explain working mechanics? It is the product of force and displacement. So what is work? According to the definition of mechanics, it is work is equal to force into displacement. That is, it is the movement of the body by through a distance d in the direction of application of force. In thermodynamics, we don't study this type of work, but we study pressure volume type of work. Which work? Pressure volume type of work, or PV work. Now what is this PV work? The pressure volume type of work is the work of expansion or contraction of a gaseous system or of a system against the external opposing force. So in thermodynamics, the work is what? The work of expansion or work of contraction of a system against the external force, that is external pressure. Now let us take the example of first expansion of a system. So let's see, suppose we have a cylinder in which there is a reaction taking place. Let's say the reaction, which reaction is taking place? Where hydrogen peroxide liquid is undergoing decomposition reaction and forming water and oxygen gas. So one molecule of H2O2 breaks down into two different molecules, oxygen gas and water liquid. Now initially the container, the cylinder, was covered with a piston, and this reaction when takes place, what happens? Due to the formation of this gas, the volume of the system will increase. Okay, Now let us assume that we have kept some mass on that piston, on the surface of the piston. You have kept some mass. When the reaction takes place and the oxygen is formed, the system will undergo expansion. Due to that expansion, the piston will rise, okay, and will acquire some other new position. Now, if we assume that there is no transfer of heat taking place, so what is the amount of energy that will be lost during for the upliftment of this mass on the piston from position 1 to position 2? Now what is happening here? When the piston moves, it lifts the mass which is kept on the piston. Okay, so this mass which is rising up to some new position is what? A work. If we assume that there is no transfer of heat taking place, we will say that the system has done the work and lost the energy in doing the work of rising this or uplifting this mass from position 1 to position 2. So the amount of work done by the system is equal to the amount of energy lost by the system. Okay, so this was the work of expansion, and the system was expanding and lifting the mass. Therefore system was doing the work against the constant external pressure. Okay, and for doing that work, the system will lose energy, which will be equivalent to the amount of work that is done by the system. In the same way, let us take the work of compression. Now let's assume the reaction of ammonia gas with hydrochloric acid gas. These two are gases. They react and form ammonium chloride salt, which is solid. Now when this happens, what happens here? Again you consider a cylinder in which this reaction will happen. So initially the position, this is the initial position of piston. Again on this piston we have kept some mass. Okay. Now due to the reaction, what happens? The two gases are combining and forming a solid. Okay. So the volume of the gas, we know this, is greater than the volume of the solid. Okay. So due to the formation of the solid, the volume will decrease and the piston will move down. Okay. The piston when moves down, it will take along this mass on it. Along with it, the mass will also come down into the position. Okay, and this will be your final position of the piston. Now what is happening here? The system is undergoing compression. Okay, and how much energy is gained by the system if no heat transfer? We are assuming that heat transfer is not taking place here. If no heat transfer is taking place, for how much amount of energy is gained by the system? The amount of energy gained by the system is equal to the work done on the system by the surrounding in pushing the piston down. Okay, so when the compression happens, the work is done on the system by the surrounding in lowering the mass on the piston. If no mass is done, then too the work is done on the system. Okay, and when the expansion takes place, the work is done by the system. Whenever the work is done on the system by the surrounding, the system will gain energy. It means there is increase in energy and the sign of work will be positive. So what happens here? When expansion takes place, it means the work is done by the system. The work is done by the system. Okay, and there is loss of energy. The system will lose energy. Okay, so loss of E. Okay. Therefore, for the process of expansion, the sign of work will be negative. Okay. In the same way, when compression happens or contraction happens, the work is done by the surrounding. Okay. And when the work is done by the surrounding, there will be gain of energy. Okay. Due to gain of energy, we will say that was a positive work. Okay. So always remember the sign convention for the expansion and compression. When the work is done by the system, it will cause loss of energy, and the sign convention for work will be negative. And when the work is done by the surrounding on the system, that is on compression, the system will gain energy and the sign of work will be positive. Why it is work? Remember, there is movement of object. Okay, the object is moved from lower to higher or higher to lower position through some distance d. So what is work? Through mechanics also we know that the work is the product of force and displacement, that is movement of object through a distance d in the direction of application of force. Okay, so here what is happening? The object is moving from one position to another position due to what? The difference in the pressure and volume, which causes expansion or compression of the system. Okay, due to this expansion and compression, the object on the piston is moving through distance d. Okay, so displacement is taking place, therefore work is taking place. Now the work would be positive or negative depending on whether the energy is gained by doing the work or energy is lost by doing the work. If energy is gained by doing the work, it means it is a work of compression, and if energy is lost, it means it is the work of expansion. Okay, so sign conventions of work and heat are very important. Okay, so these are the two important modes by which the system can exchange energy or transfer energy in an isolated process. Okay, so here we have completed the nature of heat and work. So let's finish our lecture today here only, and let's discuss the new topic in the next lecture, inshallah. Until then, please take care of yourself, be safe. Allah Hafiz.